Okay, so the first topic on radicals is restrictions. So what do we know about square rooting numbers? Square rooting positive numbers. What do we think about that? Good or not good? That's good. What about square rooting 0? Does that work? Can you square root 0? Yep. What about square rooting a negative number? No, that is not good. That's the problem. Okay, so looking at here, what will work? Can you just give me an example that works? Pick a number that would work.
8.
8, because 8 minus 7 is 1, and I can do that. Give me another one. 9, right? 9 subtract 7 is 2. That's positive. I can do that. Okay, so what am I thinking? X is going to be bigger or equal to 7. So we picked 8, we picked 9 working, 7 works. Okay? Basically, anything that is under 7 right there will create a negative and be bad, right? You might see me express this in a different way in your answer keys as well. X is not allowed to be less than 7. So I don't care how you write it, you can pick that one or that one, whatever makes sense in your brain. You might see me writing it, I'm not sure which way I wrote it in the answer key. So X has to be bigger or equal to 7. Here I'm saying X is not allowed to be less than 7. Okay, give me a value that works. What's something that would work? There's a bunch of different answers, right? Give me something that works. Anything. There's infinite answers here. 7? 7 works. Negative 4 even works, because negative 4 plus 5 is still good. Negative 5 is still good. Okay, what is not a good number to put in there? Negative 6 is when it all of a sudden starts to backfire, right? So X has to be bigger or equal to negative 5. That's what we were thinking. So negative 4, that was good. Negative 3 was good. Anything positive is obviously good. So obviously you don't have to do both methods, but I might say X is not allowed to be less than negative 5. Okay, what do you think about the next one? Give me one example that would work. 2? That works. What's an example that doesn't work? If X was negative anything, right? So X has to be greater or equal to 0 to be able to square root that. Or if you wanted to express this differently, you could say X is not allowed to be less than 0. Okay, on the last one, it's a little bit different. Think about a value that is good. 6 would be good. 7 is good. Because 8 minus 6 is still positive. 8 minus 7, that's positive. What's a number that would be bad? 9. 8 minus 9 is bad. So you were picking anything less than or equal to 8 when you were showing me what could work. 7 worked, 6 worked, Or in other words, x is not allowed to be greater than 8 there. So in that example, because that was subtracting x, that was the other way around. We know our symbols. This says greater or equal to. This says less than or equal to. Okay, adding and subtracting radicals. Okay, when you're adding and subtracting radicals, it's like terms going together. Just like combining x's with other x's, y's can go with other y's. So in this, I have root 3's can be put together with other root 3's. Root 7's can be put together with other root 7's. And so I get 2 root 3 subtract 1 root 3 makes 1 root 3. 6 root 7's plus 2 root 7's make 8 root 7's. Okay, so it's just like saying 6x plus 2x is 8x. Same kind of idea if you're thinking. Okay, so what could I put together on example 2? There's some root 5's and there's some more root 5's. Here's some root 7's and some more root 7's. So I'm going to get 7 root 5. And then there's a 10 minus 2, so plus 8 root 7. And then there's a plus 4. And I have to still bring it. I just can't put it with anything. Okay, multiplying radicals. So radicals can only go with other radicals. Whole numbers can only go with other whole numbers. That's the rule. Okay, so root 11, root 3 times makes root 33. Okay, number 2. Whole numbers with whole numbers makes whole number 8. You see where I'm getting that from? The 2 and the 4. Root 18. Number 3. The whole number is 5. That's all there was. And the radical is 5 times 8, or sorry, 7 times 8, 56. Okay, number 4, whole number make 6. Root 10 make root 100. Okay, I'm not going to leave that though. There's something I can just do with that. What is the square root of 100? 10. So now that would turn into a 60.
So if it was like square root 25, then you times that one by 5 or something?
Yeah. On your test, I would always be looking for it to break down. Okay, I'm going to actually skip this next one and then jump over. So on your homework, we'll have somewhere where we skip. Multiplying and dividing. Okay, the first example is a monomial times a binomial. So we're going to just multiply how we normally do. We have to go that through. Okay, you ready? What's the whole number? What's the radical of this set? 8 root 15. Do you see it? Now I'm going to do this combo. So this makes 4 root 21. There's a 4 and a root 21. Okay, can you try this one? See if you can get that one on your own. So multiply that and then multiply that. Okay, so the first one was a whole 8 root 70. Did that work out? And the second one has a whole number 10 and a root 49. Did we get that? And then did you think about something? What is the square root of 49? 7. So your final answer should be that. Okay, because we turned the root 49 into just a 7, a whole number 7. Okay, so division works the same way. If this is my multiplier, I have to multiply everything. If this is the divider, I have to divide everything. Same idea as the distribution, but I'm doing the dividing distribution. Okay, so this first one, 11 and a divide by 2, that makes 5.5. Root 33 divided by a root 3 makes root 11. Okay, now I'm looking at the second. So there's an 8 and a 2, so that divides to 4. A root 12 and a root 3 divides to root 4. Does that make sense? And then this is a minus 16 and a 2, so minus 8. And a root 27 and a root 3, that divides to root 9. Okay, you should notice that there's some square roots that we know. So root 4 is just 2. So that's a whole number 8. Now there's no radicals in it anymore. Root 9 is just a 3. So that turns into subtract 24. What is that? A minus? It's at 16. Okay, because I put whole numbers with other whole numbers when I was done that. Okay, number 4, a binomial. So what do we do in math once we see two binomials? We have to FOIL it all then. So first times first, let's start there. Okay, ready? Whole number 10 root 21. That's my first. 10 root 21. Okay, I'm going to go on to the outsides. Whole number 4 root 3. Okay, insides. So this is my insides. Whole number 40, radical 7. And now I'm going to do the last. So the last 8 times 2 is 16. And that radical, nope, none of them are the square root ones that I'm looking for. Okay, number 5, we're going to FOIL. Okay, so first times first makes 25 root 9. And some of you might already be thinking ahead to just 3. So there is a little bit of a thing to think about. If you have a root 3, it's having a root 3 squared. And what happens with root 3 squared? It just becomes a 3. Okay? Or root 9, and then it turns into a 3. Okay? So if you are ready for that shortcut, go for it. Okay, outsides, minus 5 root 21. Insides, plus 5 root 21. Last is subtract. Some of you might write a root 49, and some of you might write just the whole number 7. Okay, what is 25 times 3 in your head without your calculator? Money. 3/4 of money makes how much? 75 cents. What happens here with this and this? Makes 0. Minus 7. So all that comes out to 68. Okay, we are going to learn that these are called conjugates of each other. Do you see what a conjugate is? It's having the same thing, 1 plus 1 minus. And what's going to happen when you have conjugates? We're gonna work more on this one, but I'm going to FLU. I'm not going to FOIL anymore, because that's going to happen to me. Okay, you can do the whole FOIL, but if it is a true conjugate, those will 0. Okay, and number 6. I'm going to ask you to not shortcut this. If I'm doing something squared, this is what it means. If I do something squared, that's what it means. It means to repeat multiplication . Okay, and we have to FOIL. Sorry, this is not the FLU shortcut because there's not a plus minus. It's a whole FOIL. Okay, first times first makes root 25 or whole number 5. Outsides make 4 root 50. you see it? A 4 in the front and a root 50. Insides, whole number 4, radical is a 50. So plus 4 root 50 plus last. What is a 4 times 4? 16. Root 10, root 10. Root 100. Or the people that shortcut that already is knowing that it's a 10. Okay, so having a root 10 always cancels and turns back into a whole number 10. Okay, so I had a whole number 5 and a whole number of 160. So 165. And now I can put those together because they're both root 50s. So plus 8 root 50.